Hi class, let's talk about section 2.6. It's draw scatter plots and best fitting lines. So a scatter plot is something you should be familiar with again. It looks like this right here. This is a scatter plot. Ignore the line, but just having all these different points on here, this is what a scattered plot is. So just it's a graph that's got different points plotted on it. And then this one has the line of best fit drawn right in it already. So let's look at the problem. It says if your data seems to approximate a line, your job is to find the equation of a line which is closest to all the data points. This table shows the number of people, Y, who attended each of the first 7 football games, X, of the season. Approximate a best fitting line for the data. So here's our X, our number of games. Here's our Y, our people attended. A is a graph, and that graph is already done for you here. It's got the nice labels, and all the points are plotted on it. B, fit the line. So they've already drawn a line in here. Now, our job here is we're trying to make a line of best fit. So in order to actually write an equation for this, we have to start by picking 2 points. So I'm going to pick 2 points that are on the line. So if I look, my line looks like it goes through about this point, and that's the point 122. So I'm going to use the point 122 as one of my points. No, not 122, 722. That's one of my points, 722. And my other point, I want another point on the line, but none of these other ordered pairs are on the line, so I'm going to pick this spot right here because that looks like it crosses pretty much exactly at the point 2, 750. So I'm going to use that point. Even though it's not one of my data points, it does cross my line pretty much exactly. So 2, 750, I'm going to use that point. So to find our equation, we've done this for in the last lesson. So remember, our first step is to find m. If we're going to write an equation, find m, and I'm going to have to do that by using my slope formula. So I use the point 2, 750. I'm going to put it first, and then 1, 722, and put it next. 750 minus 722 is 28, over 2 minus 1 is 1. So that's 28. And my units there would be people per football game. We had an increase of 28 people per football game. So I have to still find my equation. I just found m. My second part is to find b. And remember, we substitute into y equals mx plus b. And we can use either of our points. I'm going to use 1, 722 just because they're smaller. So my y is 722. Equals m is 28 times 1 plus b. So this is 722 equals 28. It's 28 times 1 is 28 plus b. Subtract 28 from both sides. And b equals 72 minus 28 is 694. So my equation is y equals 28x plus 694. E says predict the attendance for the 10th game. So that's saying really let x equal 10 and find y. So y equals 28 times 10 plus 694. And I knew to make x 10 because if we look, x is our number of football game, and we want the 10th game. So I knew that's how I did that one. So if I simplify this, I get 974, and my units would be people. So here's my answer for E, and here's my answer for D. F says try your calculator using stats. So I will show you in your calculator, probably on another video, how to find the line of best fit using your graphing calculator and the statistics function. It's really not a difficult thing to do. It'll go pretty quickly. Let me move my page up here. So let's look at some of the vocab associated with this. I'm going to make my page a little bit larger so I can see better and write clearer for you. So scatterplot is our first vocab word. A scatterplot is just a graph of a set of data pairs. A graph of a set of data pairs. That's what a scatterplot is. The best fitting line, well, this is a line that lies as close as possible a line that lies as close as possible to all the data points. And one thing to remember is about half of your points are above and half below. So when you draw your line of best fit, you should try and draw it kind of right through the middle of the point so that you have half above and half below. That's an and symbol. Positive correlation. So now we're going to talk about correlation, and correlation talks about how things are related. So positive correlation means that Y tends to increase. As X increases. So a negative correlation would be that Y tends to decrease as X increases. And then the last vocab here is the correlation coefficient. And this is R. We use the letter R to represent our correlation coefficient. And the correlation coefficient, this is the number from -1 to 1. So a number from -1 to 1. And this measures, so a number from -1 to 1 that measures how well a line fits a set of data. Okay, so here's something to remember. Okay, if R is near 1, it's close to a line with a positive slope. And then if R is near -1, that tells us it's close to a line with a negative slope. It's a negative sign right there. So turn the page over and we'll talk a little bit more about correlation coefficients. So let's look at some examples for R values. So looking at this first one here, if R is -1, or it's pretty close to -1, it's going to look just about like this. We could draw a line and it will go down. R about equal to -0.8. See, if I drew a line going down through this, the points are still going to be pretty close to that line, but not nearly as close as they would be if I drew a line right here. R equal to -0.55. If I drew a line right down the middle here, again, my points are going to be close to it, but not as close as in these other two situations. And notice that all the lines I drew here are going down. That's why the R values would be negative. For this picture right here, R equals 0. If you notice, there's really no one line that is any better than all the others. For this one, R equals 1. I could draw a line going right up through, pretty much through all those points. Okay, so when R, let's see here, I'm trying to get a pen. When R is exactly 1, the data points are all on the line with a positive slope. When R is close to 1, the data points are close to the line with a positive slope. When R is exactly -1, the data points are all on the line with this time a negative slope. When R is close to -1, the data points are all close to the line with the negative slope. And then when R is near 0, the points do not lie close to a line. So let's look at this next part here. We're going to tell whether the the correlation coefficient is closest to -1, -1/2, 0, +1/2, or 1. So looking at this problem right here, if I drew a line right here, those points are all going to be pretty close to that one, okay? And that line would be going up. So I know my options are 0.5 or 1. It's not 0. 0 is when there's really no line that fits it. It's going to be 0.5 or 1, but we're talking about closest to these two. And so I'm going to say it's going to be closest to 1. Let's look at this last one here. Now this, if I drew a line, it would come down like this, so we know it's negative. And our options are -1 or -1/2. If you notice, if I drew a line here, these points are spread further from that line than in this previous one that we just did. So it would be closest to -1/2 for this one. And then for this middle problem here, really there's not one line that all the points are closest to. So we're going to say this one is closest to 0. So this correlation coefficient portion of this lesson is probably new to you. It's probably something you haven't heard of. Remember to look for a video on finding scatter plots on your graphing calculator, and we'll talk about also how to find the correlation coefficient exactly on your calculator. But make sure you start any questions that you had, or any parts you had questions on that didn't make sense, and we'll talk about them in class tomorrow. Have a great night.